All right, guys, let's take a look at 9.1 and 9.2, our new module, module 9 on properties of quadrilaterals. So 9.1 and 9.2 talks about properties and then the conditions for showing that a quadrilateral is a parallelogram, okay? So for the learning target, I can use the properties of parallelograms to solve problems and to verify that a quadrilateral is a parallelogram. Okay, so let's take a look at the definition. So the definition of a quadrilateral is that, of a parallelogram, I'm sorry, is that a parallelogram is a quadrilateral whose opposite sides are parallel, okay? So both opposite sides are gonna be parallel. So in this case here, AD is parallel to BC and AB is parallel to DC. Okay, and in order to name a quadrilateral parallelogram, you just use this little figure of a parallelogram, and then you start with one of the vertices, and you either go clockwise or counterclockwise. It doesn't matter, but you can't skip count. You know, you have to go in order. So it's either parallelogram A, D, C, B, or parallelogram A, B, C, D, or you can start with C and say parallelogram C, D, A, B, and so forth. Okay. Now here's some vocabulary. Opposite angles are angles that do not share a side. So in this case, angle A and angle C are opposites. Angle B and angle D are opposites. Consecutive angles are angles that share a side. So for example, angle A and angle B, they share the side AB. So they are consecutive angles. Um, Remember that every angle has two consecutive angles, okay, on a parallelogram. So for example, angle A has B for its consecutive angle and also D, okay? So each vertex has two consecutive angles. Diagonals are segments that join non-consecutive vertices. So they go from one vertex to its opposite, okay? So they join opposite angles. In this case, the diagonals here are diagonals BD and diagonals AC. Okay, so now let's look at some important properties. Just to emphasize, the first thing you need to know is that the opposite sides are parallel. So if the opposite sides are parallel, it's a parallelogram. Okay, that's the definition. Now for the properties, we know that opposite sides of a parallelogram are congruent. Okay, so AD is congruent to BC, AB is congruent to DC. Also, opposite angles of a parallelogram are congruent. So angle A and angle C are congruent, angle B and angle D are congruent. Consecutive angles in a parallelogram are supplementary. Okay, so angle A plus angle B will give you 180. Angle A plus angle D is 180. Angle D plus angle C equals 180, okay? So every time you have consecutive angles, they add to 180, okay, in a parallelogram. The other feature here, the other property here is that the diagonals of a parallelogram bisect each other. Okay, so if you have the diagonal here BD and diagonal AC, I know that point P is the midpoint of BD and the midpoint of AC, okay, which creates two segments here that are the same. Okay, so BP is the same length as PD, and then AP is the same length as PC. Okay, notice that they're not equal. Okay, the diagonals are not the same measurement. Okay, and these halves here are not going to be the same measurements as these halves here. Okay, so that doesn't apply. Um, Okay, so now I put some videos there that I would strongly recommend you watch, okay, to help you understand more this concept of parallelograms and using the properties and so forth. Okay, let's look at an example. So now I have an example here where I'm asked to draw parallelogram HKLP. So I drew here the parallelogram HKLP, okay? And now I can get some information. Okay, so I know that HK, okay, HK here is going to be equal to LP. Okay, so I know that this side is equal to this side, right? They're opposite sides. I know that this side is going to be equal to this side. Okay, I know that. I also know that they're parallel, right? So this line is going to be parallel. This segment is going to be parallel to this segment, and then this segment is parallel to this segment. Okay. So if angle K, the measure of angle K is equal to the measure of what angle? So angle K right here, right? Remember, opposite angles are congruent, so it's equal to the measure of angle P. And the measure of angle L plus the measure of what angle is equal to 180. So angle L, you can pick two, right? Angle L plus angle K will be 180, or angle L plus angle P would also be 180. So here it could be K or P. If the measure of angle P is 65, so if angle P here is 65, right, then what is H? Well, they're supplementary, so it's 180 minus 65, which gives you 115. Now, angle P is 65, which makes angle K also 65 because opposite angles are congruent, okay? And the measure of angle L, well, K is 65. So K and L are consecutive angles. So that means they're supplementary. So when you do 180 minus 65, you get 115 for L. Okay, or you can use the idea here. Look, you already know that angle H is 115. So you know that L is also 115. Now draw in the diagonals and then label that they intersected at point M. So I drew here the diagonals, and then here is point M. Okay, so now there's something I know here. I know that this here, right, is congruent to this segment right here. Okay, and I also know, let me change the color, and I also know that this here, okay, is going to be congruent to this one here. Okay. So now let's look over here. If HM is 5, so I have HM here is 5, then ML, remember they're congruent, and it's the midpoint, it has to be 5. If KM is 7, that means that KP, so look, KM is half of KP, okay? So that means you double and you get 14 for KP. Then if HL is 15, so HL is 15, then what's ML? Well, HL is double ML, so it has to be half, so it's 7.5. And then the last one here, if the measure of angle HPK, so we're talking about this angle right here, is 36, then the measure of PKL is what? So P KL right here. What is this measurement going to be? Well, let's think about this here. If I have two parallels right here, cut by this transversal. So let's say PK is the transversal, and then I have the two parallels right here. Okay, so these would be alternate interior angles, which make them congruent. Okay, so that means that angle PKL, the measure is 36 as well. Let's take a look at example 2. So now I have ABCD is a parallelogram. Find each measure. Okay, so I know that BC is 5x plus 19. I know that AD is 7x. Okay, I know that because this is a parallelogram, I know that opposite sides are congruent. That's one of the properties. So in order to find AD, I just make one side equal to the other. So 5x plus 19 is equal to 7x. Subtract 5x from both sides. I end up with 19 equals 2x. When I divide by 2, x is 9.5. Okay, so when x is 9.5, this ABC is congruent to AD. Now I want to find angle B. Well, angle B is 6y plus 5. Angle D is 8y minus 17. So what's the relationship between opposite angles? Well, opposite angles of a parallelogram are congruent. So you just set these two expressions equal to each other and solve for y. 6y plus 5 equals 8y minus 17. Subtract 6y from both sides. Bring down the 5 equals 8y minus 6y is 2y minus 17. Then when you add 17 to both sides, you end up with 2y equals 22. And when you divide by 2, you get y equals 11. So when y is 11, these two angles would be congruent, and that would make it, would confirm, right, that it's a parallelogram. Okay, let's talk about tests for parallelogram. Okay, so let's look at the property that we've already mentioned. If a quadrilateral is a parallelogram, then opposite sides are parallel. Okay, so that's the first thing you have to remember. Okay, that's the definition and the first property. Okay, this is the first theorem right here. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we've talked about this, the fact that opposite sides of a quadrilateral are congruent, right? There is a parallelogram. If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. Okay, so now if I take a look at one pair of opposite sides, and if I can confirm that they are parallel and they're also congruent, then I don't need to look at anything else. I know that the quadrilateral is a parallelogram. The next one, if both pairs of opposite angles of a quadrilateral are congruent, then it's a quadrilateral. Then the quadrilateral is a parallelogram. Okay, so if I take a look at a quadrilateral and I can confirm that the two pairs of opposite angles are congruent, say they're the same measurement, then I can say, okay, this quadrilateral is a parallelogram. And then the other way to show is by the diagonals. Remember, the diagonals bisect each other. So if I can show, if I'm given a quadrilateral with the diagonals, and I can show that the diagonals bisect each other, then I'm proving that the quadrilateral is a parallelogram. Okay? So to prove that a quadrilateral is a parallelogram, you must show one of the property theorems above. Okay, so these things we just discussed, you need to show one of those. So I kind of listed them here. Both pairs, you need to show that both pairs of opposite sides are parallel, show that both pairs of opposite sides are congruent, show that both pairs of opposite angles are congruent, show that one pair of opposite sides are both parallel and congruent, and show that the diagonals bisect each other. So now you only need to show one of these. If you show one of these, then you've proven that's a quadrilateral, okay? All right, so here I kind of made the examples for us to see 5 ways for us for me to show you the 5 ways to prove that a quadrilateral is a parallelogram. Okay. So the first one here is to show that both pairs of opposite sides are parallel. So remember, parallel, you have to look at the slopes to see if the slopes are the same. Parallel lines have the same slope. So over here, when I start here on the vertices, right, I want to check and see that this line right here, okay, is parallel to this line. Okay, so in order to check that, I need to show that they have the same slope. So rise over run. So the rise from D to C. So I go up 1 and then over 1, 2, 3, 4, 5, 6, 7, 8. So the slope is 1/8. Now let's look at this one, AB. Well, I go up 1 and then over 1, 2, 3, 4, 5, 6, 7, 8. So that's also 1/8. 1/8. So that means that these two lines are parallel. Okay. Now I need to check that the other lines, the other opposite lines are parallel. So let's look at this one and this one. Okay, so I need to check and see if that slope, the slopes are the same. So let's start at D. I go down 1, 2, 3, 4, 5, 6, 7, and then over 1, 2, 3, 4. So this, because it's going down, it's a negative 7 over 4. Let's look at the next line. Rise over run. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So negative 7 over 4. So because those slopes are the same, it means the lines are parallel, which means that this, this quadrilateral, ABCD, is a parallelogram. Okay. Now, the other way to show it is that by showing that both pairs of opposite sides are congruent. So here in this case, I have this side, y plus 2, and this side, 2y. So when I set them equal to each other and I solve, I end up with y equals 2. So I've shown that they are congruent. Then I have to show the other pair, 6x equals 4x plus 8. When I solve this for x, I guess x equals 4. Okay, so by finding x and y, I've shown that the two opposite sides here are congruent. Therefore, this quadrilateral is a parallelogram. Okay, let's look at the next one. Okay, so now I have show that one pair of opposite sides are both parallel and congruent. Okay, so because I have this picture in the coordinate plane, I am going to use the horizontal line because that would be the easiest for me. Okay, like AB, side AB, and side DC. These are horizontal lines. I know that horizontal lines have a slope of 0. They're both horizontal. They both have the slope of 0, which means they're parallel. Okay, so I just confirmed that they are parallel because they're horizontal. Okay. The other thing I have to confirm now is the length, okay? It's not, you can't really see the grid here on mine, but on your notes, you should be able to see the grid. And if you count, okay, from A to B, you get 6 units. And then from D to C, you also get 6 units. So that means that AB is congruent to DC, okay? So I've shown that the two opposite, those opposite lines, those opposite sides are both congruent and um, um, parallel. Okay, so I've shown that this quadrilateral ABCD is a parallelogram. Okay, let's look at showing that both pairs of opposite angles are congruent. Okay, so this is kind of similar with this one that I have to show the sides, but now I'm using the angles. Opposite angles are congruent. So 5y has to be equal to 60. When I solve, I get y equals 12. 2x plus 8 equals 120. So when I solve this, I get x equals 15. So when y is 12 and x is 56, this quadrilateral is a parallelogram because I've shown that the opposite angles are congruent. The last one is showing the diagonals bisect each other, okay? So remember that if the diagonals bisect each other, I have to show that it's always the midpoint here of AJ. So if O is the midpoint, that means that HO has to be congruent to OJ, okay? So I said x plus 40 equals 2x plus 18. So right here, I have 2x plus 18 equals x plus 40. So when I solve this, I get x equals 22. Now, I'm also given that KO is 17. So if KO is 17, that means that OI also has to be 17. Okay. Now go back on the lesson and do practice all of your turns, and we'll discuss this in class and practice some of these problems in class as well.